Bismillahirrahmanirrahim. Assalamu-Alaikum and a warm welcome to all of you from our team in our fourth step and concluding webinar of the webinar series entitled as Steps Towards Quantum Computing World. I'm really thankful to all of you, those who are with us from the beginning and all those participants who joined us for the first time. You all are welcome and appreciated. I hope you all learned a lot. And in this webinar, we'll discuss something about applications of quantum computing and its future aspects. It's an important note. Participants, please put your name in chats along for the certificate and kindly remain unmute for the whole session. And it's for all the participants who are speaker today. Kindly hand over your host to Muhammad Mooazam. Okay, let's start the session with the introduction of QCC. Thank you so much. QCC, abbreviated as Quantum Computing Club, is a group of students that are aimed to be a society for the promotion of quantum computing. It was established in 2019. We aim to promote the most fascinating quantum technology, quantum computing, among students, especially to the tech geeks. We are working to make people aware of it and to provide them a platform for collective learning. As I told you about us, that we are a group of students from ND University of Engineering and Technology, and we are working for the promotion of fastest growing quantum technology among other students. We aim to take forward our country in the research and technological developments in quantum world. If you want to join us and work with us, you are highly encouraged to contact us to do something better, something more interesting and amazing. Our mission is to spread quantum computing knowledge among the tech students and to promote research in this field. We aim to provide platform for collective learning and research to the student and facilitate the students to have a practical implementation in this field. We have some of the past events that include IBM Quantum Challenge webinar, in which we discussed about the 4th May challenge of IBM and its detailed solution of exercises. Our next step was the webinar series named as Steps Towards Quantum Computing World, in which our first webinar was Introduction to Quantum Computing, where we discussed some of the important aspects of quantum computing along with its physics behind it. Our second webinar was Working of Quantum Circuits and Superconductivity in Circuits. Our third webinar was in Non-Universal Quantum Computing, where we discussed non-universality of quantum computing and its implementations. And it's the fourth and final step and a concluding webinar of the webinar series named as Real-World Applications of Quantum Computing. We will have some other events in near future, but the webinar series we started to have some information and some awareness about quantum computing to our students and our fellow beings who are fascinated with the term quantum computing and don't know much about it. So it was for them, and now we'll move towards some of the higher research and other things in near future. You can contact us through email at quantumcomputingclub79@gmail.com. We have our Facebook page named as www.facebook.com/Quantum Computing Club. You can also watch us on YouTube, and we have uploaded all of our webinars on YouTube along with the slides and related links. You can also find us on YouTube, and we have our LinkedIn. You can see in slides, and we will also provide links, so you can also connect us and follow us on LinkedIn, and we are on Instagram. You can connect with us. So it was little about UCC. Now I want to invite Ms. Nazish Fatima to have a little introduction about CPE, Center of Physics Education, because this webinar series was in collaboration with CPE, that Center for Physics Education, working for the physics. Okay, so
Thank you, Iqra.
Ma'am Nazish Fatima, can you hear me?
Yes, I can.
Okay, over to you. Thank you.
Okay. All right, I'm good to go. I can see Dr. Jamil in the gallery. So with his permission, I would like to start the introduction because he's one of the main, you can say, in CPE and one of the founders of Center for Physics Education. So the introduction for Center for Physics Education, it is an organization that is working to promote the physics education in the form of active learning and conceptual understanding among students, teachers, researchers, professionals, and we are not limited to only educational field people. We are open to everyone who have passion for physics here. So CP was founded in 1985, and since 1985, CP has been organizing conferences, seminars, workshops, at international and national levels. And obviously, in such a short time, it will be very difficult to cover all aspects of CP, all activities that CP, Center for Physics Education, have been organizing and facilitating. So I will give you a quick review of Center for Physics Education, what we have been doing, and what we have done previously in past, and what is our future. Now, Center for Physics Education have been highly recognized by international organization. Especially, I have mentioned here the name of Center of Theoretical Physics, Italy, who's also founded by Dr. Abdus Salam, who's founding patron of Center for Physics Education as well. UNESCO, Asian Physics Education Network, PAC and Sparkle. We have gone through all the programs with them. We have collaborated with them, and many more. These are just few highlighted ones. And as Center for Physics Education have been highly appreciated by international organization, we have been trying our best to continue the activities to bring change in teaching and learning pattern and environment, especially in educational institution, and also to bring awareness in all in people from all aspects of life. So, and we are highly fortunate that in 1991, the first Nobel laureate of Pakistan, Professor Abdus Salam, had agreed to be the founding patron of physics. And CP is really very fortunate to have him as its founding patron. And this represented Pakistan at ASP and ICW IP, that is International Commission on Women in Physics, and we have been doing activities and programs under those banners as well. Now, the members we have are from all aspects of life, including the members from school. CP have now vast number of members, registered members, unregistered members, volunteers. They are from schools, college, universities. They are teachers, professors, researchers, and also the parents of the children and students who are so keen for their children to learn and excel in the field of physics. So everyone is invited to work with CPE, and everyone is invited to collaborate with CPE, and we are open to everyone. So our members are from very diverse field of life that are the main purpose of those, and the main passion of those members is physics. Now, Center for Physics Education was founded in 1985. The journey accelerated. The first main highlighted project and big project of Center for Physics Education was to setting up a computer-based lab as a model teaching lab at Upper Government Degree College for Women. And that was a very huge project, and it was launched in 1995. The project was initiated in 1990 from with collaboration with the university, Adana University, Turkey, and this Fatima Snan, who is also General Secretary of Center for Physics Education. And then this project was launched in 1995 and have been a huge success as a model teaching lab teaching lab for physics in colleges and educational institutions at that time, using computer-based teaching and learning environment. Now, since that time, we have gone through a lot of milestones and organized a lot of activities that includes fun and amusement in physics. As we all know that physics have been under the image of being a very dry subject, and that is not it, obviously. So our purpose also was to introduce and to make an image of physics that is that is not a dry subject, that is fun and amusement. And we have been doing activities by creating an active learning environment for it, instead of just going through the curriculum and learning lots of formulas and memorizing the statements of laws. So we have been celebrating birth dates for a prominent physicist, and one of which is Salam Day, Einstein Day, Faraday's Day, and Galileo Day, that have been organized and celebrated on regular basis every year. And these were organized to motivate students to go forward for physics, and to teach them that physics is not an alienated subject, but it is also a subject that covers all aspects of life. And we have also organized activities and international workshops like ELOP and FISWare. I will be showing the pictures of these activities later on, if the time is not overwhelmed, and the conference which were organized. And these are some of the collaborators, not all of them, these are some of the international collaborators we have been working with. That is ICTP, International Center for Theoretical Physics, International Conference on Women in Physics. They under which many of the international conferences have already been organized. UNESCO, we also work with the collaboration with the UNESCO on different projects, and scientific and cultural organizations. We have also collaborated with Pakistan Atomic Energy Commission, SUPARCO, that is Space and Upper Atmospheric Research Commission in Pakistan, and also Asian Society for Physics Education Network. These are not all, but some of the collaborators we have been working with. And since we have got a lot of acknowledgement and support from international organizations, we are representing Pakistan at international level through international activities, and everyone is invited in the activities that CPE is holding and facilitating. That includes not limited to teachers, researchers, and also we have got lots of international representatives that join our events. I'm not going to go through the whole detail of this, you can say, CPE team, just an overview. Whoever want to read it in detail, this PPT will be available afterwards, so you can go through it for the details again. So our chairperson is Dr. Akila Islam, General Secretary is Fatima Hasnan, and these are two people who are the main, you can say, soul of Center for Physics Education. And we are very, very thankful so that they have organized this kind of platform for promoting physics, teaching, learning. Our advisory, this is our advisory committee, our finance secretary and joint secretary, and these are some of the executive member of CPE who have been with CPE from the start till today. Now I will be giving you a little highlight, pictorial highlight, not in detail, of some of the activities that CPE have been organizing in past few years. I couldn't find the pictures of very old activities, but these are some of the main activities. And keep in mind, these are not all of the activities because we cannot fit all these so many years from 1985 to 2020 in 5 minutes PowerPoint presentation. So these are some of the highlighted activities that we have done. In 2015, we celebrated International Year of Light, and there were some workshops, conferences on active learning in optics and photonics. It was jointly organized by National Center for Physics Islamabad and Center for Physics Education. You can see these are the glimpses of some photographs of that workshop. Also under that banner of International Year of Light, there were several other programs. Fresnel and Wave, to workshop on Fresnel and Wave nature of light, and a workshop to train teachers in making science more accurate. Now, I'm not going to go through this because this have all the dates available for Center for Physics Education activities. So this is the whole detail of International Year of Light celebration. The second activity that I would like to mention is the Regional Conference on Women and Physics that was held in April 25-27 in 2016. It was jointly organized by ICTP, National Center for Physics Islamabad, ICTP, that is International Center for Theoretical Physics, Trieste, Italy, and Center for Physics Education. So it was a conference that was to highlight the role of women in physics research and physics teaching, and to promote women in physics, and to promote women to confidently join the field of physics and excel in this field. These are some pictorial pictures from that event. These are the posters Center for Physics Education shared in the conference. And if you want to go through the details, you can go through these details afterwards in the PowerPoint presentation. One of our activity have been the workshop for students from low facility schools in Pakistan. So these are the schools which do not have laboratory facilities or who do not have privilege to high tech instrumentation. So Center for Physics Education organized every Friday a workshop for the students from these schools on every Friday from October 2016 to December 2016, and it was a success because lots of students joined and showed interest in these workshops. These are some pictures from those workshops, and if you want to go through the details, these are the details for the workshop here. Also, we have been organizing different science exhibition and collaborating with different colleges and educational institutions to organize science exhibition, one of which was 21st October 2016 at DHE College, and there are many more that have been organized, so I have not put those here. There was another workshop that was held in 2017 February for SOS Village children, and it showed, and the turnout was very good, and it showed that the learning intelligence and learning capability do not depend on the facilities that are given to the students. Another regular basis celebration is we celebrate the birthday of Dr. Abdul Salam as a Salam Day, and usually these are workshops, these are seminars, these are conferences. Every year we celebrate that to pay tribute to Professor Dr. Abdul Salam. These are some glimpses from the event, and you can see that the event as all people show interest in these events, and they get very promoted towards physics. And this is the detail of one of the Salam Day celebration programs. Another celebration that is another day that is celebrated on regular basis for birthday of a scientist, that is Einstein Day, and it includes different workshops, if you can see, there is a workshop on teaching of relativity. That is a very hard subject. So this is the detail of the seminar and a conference that has been organized. Another conference that Center for Physics Education have organized, that is International Conference on Research-Based Physics Education for Sustainable Development. It was a conference that with collaboration with the Pakistan Atomic Energy Commission, PNRA, and a lot of international speakers were there. And this is a short summary of the program that was included in the seminar and the titles of the talk. All right, now I will just move through the pictures because this is one of the workshops that we did for physics research learning by doing in June 23rd to 26, 2014. This was basically for research students to develop the research understanding of research-based physics study and learning, and how to train young researchers that how to write down a research thesis, how to write down a research manuscript, how to build your skills towards research. So this was a very informative workshop, and it had lots of mentors to train. It was a 3 days workshop. This is the brochure of CPE, and this is one of the program that is named as Charisma of Light. It was an exhibition and a workshop on light-based technology. There are some glimpses of the activities for Center for Physics Education. This is a LOP workshop. This is the exhibition, poster exhibition for school and college students on the topic of energy resources. And this is the glimpse for conferences, international conferences from Pakistan. This is the workshop of PhysWare, international workshop for PhysWare, and the participants in it. And you can see that this is a very workful field. And also we are so proud of doing something that is highlighting the subject in young researchers, young students, and promoting physics as not as a very dry subject, but promoting it as a very interesting and colorful subject that has influence in all aspects of life. Thank you very much. And over to you. What should I do?
Ma'am, Iqra will continue.
There's a quote by Ernest Rutherford.
Mm-hmm.
All of physics is either impossible or trivial. It's impossible until you understand it, and then it becomes trivial. A very well speech done by Ma'am Nazish Fatima, that was the executive member of CPE, Center for Physics Education. Thank you so much, ma'am, for
You're welcome. And I would like to mention here that Dr. Jamil is here. He is one of the heart and soul of Center for Physics Education. So it's an honor to represent CPE in his presence.
Yes, ma'am, it's an honor for us to be with her. Thank you so much for being with us. Okay, now our next speaker is Syed Muhammad Mooazam, who will discuss about the glimpse of quantum technology and its progress around the globe.
Assalam-o-Alaikum. My name is Syed Muhammad Mooazam. I'm a student of electrical engineering in NED University, Karachi, Pakistan. I am founder and president of Quantum Computing Club, and today the topic of my webinar is a glimpse of progress in quantum computing technology. Now let's jump into the topic. Now there are some benefits of using quantum computer over a classical computer. If we are building quantum computer, uh, we are paying a lot of expense for it, then there must be benefits for it. So let's discuss some benefits of quantum computing. Here I first mentioned cryptography. We all know that cryptography is one of the major benefit of quantum computing. We can do quantum cryptography using quantum mechanics properties like superposition, entanglement, and interference, and we can do quantum cryptography, which is a lot more beneficial than a classical cryptography. We take an example that if we made about 80 qubits quantum computer, then there will be no classical cryptograph system that cannot be decoded by a quantum computer. That's the power of a quantum computer. Now, another benefits of quantum computing is complex calculation. We all know that when calculation becomes extra large or extremely complex, that classical computers cannot hold it. So here's come the benefit of quantum computer, that it does its job quite perfectly. Um, Next important thing is data analytics. We all know that it's the time of artificial intelligence, it's the time of data analytics. We all know that the most expensive thing in the world right now is data. All the big companies wants to get their data, and if they want to get the data, they must uh, have something for its analyzation, and here it comes the data analytics part. Using quantum computer, we can make many things possible with in data analytics part. Okay, so other important thing is weather forecasting. uh, Weather forecasting is a major application of quantum computing. We can take an example that about 30% in USA, actually, I guess in USA 13 about 30%, the weather forecasters give report late. That means classical computers take a lot of time for their calculation about weather forecasting, and most of the time their forecasting gets late, and USA gets a lot of loss for it. And so it will all be saved by using a quantum computer or using quantum mechanics properties in a quantum computer. Okay, so other major benefit is in medical research, the things which will be further discussed by our next speaker, Muhammad Miqdad. But let me do some brief about it, that there are some limitation of classical computer, but when we talk about quantum computer, so we get a lot of room for medical research and its simulation and its algorithms and things like that. Other major benefit is of quantum machine learning. Yes, you are right. It's machine learning in quantum computer. So some applications like I want to discuss about benefits of quantum computing is of disease diagnosis. You can do disease diagnosis very easily using a quantum computer. Other is fraud detection, and things like energy efficient system goes well for in learning part. And something like materials, quantum computer can also be used in materials side, like chemistry, high energy physics like that, and things like that. We can also do risk analysis using a quantum computer, in which quantum computer is a lot of provides a lot of benefit rather than a classical computer. Moving ahead, here is some development side in quantum computer, that where is world. Let me clear, I am showing only 4 companies which is developing a quantum computer, but there are many which are doing researches and doing things, developing things, promoting. They are doing a lot of stuff, but I'm mentioning the top 4, you can say, that are doing a lot of work in quantum computer. The first name is, of course, the IBM quantum network, the IBM quantum experience. They made a quantum computer consisting of 53 qubits. It uses superconducting technology for making its quantum chips. They have a good community. You can check out them on Slack and IBM Quantum Experience. You can use their quantum computer using cloud and things like that. There are a lot to be done in IBM Quantum Experience and things. Other important is Google's Sycamore. It uses 53 it is a 53 qubit machine. It uses superconducting technology for making qubits. Here you can say its CEO Sundar Pichai, along with it, quantum computer made, basically it's the property of Google. Okay, so next is D-Wave. D-Wave is doing a great work. They have made 128 qubits machine. They are using quantum annealer technology and superconducting technology for developing their quantum computer. Here you can say that in the picture, it's the outbox of D-Wave. Here it's the processor, and it in the center you can see the
Excuse
now moving further on. It's the computer of Honeywell.
me.
It uses strap band technology for their quantum chips, and it consists of 6 qubits machine basically. Okay, so at
Hello.
last, thank you so much. Type.
Thank you so much for your concern. We'll have question answer session in last.
We
Uh,
have it right now after
You can
this.
also
you
put
can
your
also.
question in chats.
I'm just
We can do one question,
uh,
I guess.
like somebody to tell me what quantum computing is. What is its basis? What to do?
Okay, you are asking about the basic of quantum computer. What
Yes.
quantum computer is basically?
What is
Basically, it's not the topic. Basically, actually, we already discussed in our previous session, and it's the series. But our next speaker, Muhammad Miqdad, will show some light on it. You can hear about it in a few bits. So
Okay.
I'll hand over to Iqra Naz. Please continue.
Okay. Thank you so much, Muazzam. It was a nice presentation. Now, our next speaker is Muhammad Miqdad, who will discuss quantum computing in medical technology. Over to you, Miqdad.
Miqdad, it will be best if you will show a little bit light on the basis of quantum computing orally, so that those participants who are new to us can grip the topic. Okay.
Okay.
All right. Thank you.
If you suggest, I will share some slides also.
Okay, that will be good.
Okay, for some participants who are new in this technology, so what is quantum computing? Quantum computing and what is quantum computer? A quantum computer is a machine that performs calculation based on the laws of quantum mechanics. I name here the quantum mechanics. The quantum mechanics is the study of the behavior of the subatomic particles. Okay, this is the real picture of the quantum computer. History, I skip it. And what is the I skip this all because we discussed these things all before. Achha, representation of data or qubits. This is the blogosphere. In this form we represent the qubits. There is the difference between the bit and qubit. Bit is the data representation. Bit is the 0 or 1 states. Bit has only 2 states, that are 0 and 1, but qubit is something different with the bit. It is the same in the forms of input and output. It takes the input data in the form of 0 and 1 and gives output in the form of 0 and 1 also, but it is different in the form of processing, as it process using laws of quantum mechanics, that are superposition, entanglement, etc. So the n qubits will be equal to the 2 to the power n classical bit. Here is the representation of some conventional bit using photonic bit. In this is the photonic source, and there is the switchable mirror. And if we switch the mirror here, then it will be the 1, and then it will be the 0. And it is the representation of the photonic qubit. Qubit, in it we use the I'm sorry, it is this half silvered mirror in the superposition state. The photon is in the superposition state, that will be 1 and 0 at once. I think it is enough, Ma'am Nazish. In the layman terms, a quantum computer is working with the multiple states at once, and the classical computer will work on the single state at a time.
Mhm.
That is
In fact, classical state has 2 states, right? 0, 1
yeah,
presence or in presence of electricity.
yeah.
Quantum states can be multiple states at the same time. And what is the quantum? We have electronic current, right? Over there, it is a photon, basically. The state of a photon is measured, right? And at a certain time, electric signal can be 0 or 1, but at photon can be multiple states. And it can be up to, how many states it can be up to in a single, for a single photon? How many different states can
it can be infinite states, as there is the probability function.
Yes. So based on the probability, it can theoretically it can be infinite states, but when you make a quantum computer, you limit your number of states for each qubit, right?
Mm-hmm.
Yeah.
So you can, based on how much probabilistical your hardware can work with the quantum probability of the states, you can increase the number of bits in one photon.
Yeah,
Thank you, Khurram
equation.
and Miqdad.
So one photon.
Thank you so much to both of you. Sorry to interrupt, but we have limited time and we have already our speakers with limited slots. So kindly avoid you to unmute yourself and don't ask questions by in voice. Kindly drop your questions in chat. We'll answer you in the last of the session. And if we can't, we'll answer you through email. Thank you so much for your participation.
Okay,
Let's
now
move towards our main topic.
Okay, I'm moving on our main topic here. Quantum computing in medical technology. It is the most crucial application of the quantum computing in nowadays. There are some fields of application of the quantum computing that are cryptography, medicine and material, machine learning, searching the big data, and all of these 4 applications are in the use of the medical technology also. So we are going to discuss quantum computing for healthcare. In the quantum computing for healthcare, there are 2 main applications: improving imaging solutions and improving therapies. In the improving imaging solutions, quantum imaging machine can generate extremely precise imaging that allows visualization of single molecules. And the improved therapies, the ability of quantum computers to handle complex problems, can help physicians to determine the best therapy plan for a patient. We will discuss these in the detail. Now, these are some topics of the discussion. What quantum computing do for healthcare? These are some drug design, sequencing and analyzing DNA full speed, making patients truly the point of care, arriving at the perfect decision support system, creating the safest medical data systems ever. Okay, let's start with the drug design. In the drug design, with the use of quantum computation, it is possible to design the drug with the low cost and in the less time, as quantum computers are really faster because they use the laws of quantum mechanics and the superposition and entanglement, which makes them really faster. Even the supercomputers are really slow in the with the competition of the quantum computers, as we see some companies AtomNet screens more than 100 million compounds per day. If we use the quantum computer, we can do more compounds in a day, as we are in the need of ground state energy findings. With the help of quantum algorithms, we can do even better, as there are some algorithms are there. For example, variational quantum eigensolver algorithm, which will help in the finding the ground state energy. These are some applications of computing technology in medical, that are the IoT, healthcare professionals, smart devices, and the social media and the research centers. All can be used, all can be done with the help of quantum computation. But I will not suggest to use the social media with the quantum computation. Classical computers are enough for the social media. Sequencing and analyzing DNA full speed. It took around 15 years and billions of dollars in research of decoding DNA radical changes. But with the help of quantum computation, we can do it really fast, as we can do the searching and sequencing in a single run. But I have some animations for you, and that can help you understanding, like classical search. Search basically sequence. In the sequence, we have to use searching algorithms also. I'm also working with some of other researchers to making some algorithms to sequence the genomic data in the quantum computation. If we able to use the quantum computation in the in this global pandemic era, most probably we have been found the vaccine of coronavirus before before that today. In the classical search, here is the some animation for understanding. This is our lab mice, and it is hungry. He has to find its food for him. So if we run it, see, it goes every way one by one for searching the food. Again, but in the quantum search, the things are really different. It is our Schrodinger's cat, and it is also hungry. She has to find the mice. So if we run this animation, then see what will happen. It will go every way at once, because it is in the photonic qubits, and qubits there are multiple states that can run at once. That's why when the quantum computation finds the way that are multiple ways, it will go at once. In the sequencing, it is very useful, like Grover's search algorithm, etc., making a patient truly the point of care. Like here is the one problem with the medical data safety. There are some algorithms in the quantum computation for cryptography. We have a session for cryptography in this webinar also, like so that will be discussed in the details. And there are lots of data of patients, like like 44 trillion bytes or 4.4 zettabytes data. It has to be secure. For securing the data, quantum computers are the best thing. Like there is some theorems of the no cloning theorem, no copying theorem. Because of that, the data is secure. If an wanna theft our data, then there will be the destruction in the data, and he will not get the real data. Robotic surgery and the artificial intelligence points. Like in quantum computation, we can do our machine learning parts and diagnosis parts very easily, because they are really fast and can do multiple things. Like if we are in the practice and exercise experience of the machine learning using CPU and GPUs also. If we use the CPU, there is no good learning, and in the use of GPU, there is a good learning, and GPUs are also fast. And if we use the quantum machine learning, there will be the more efficiency. And with the use of quantum computation, we can make sensors and decision power really faster. And safest medical data I have discussed before, and due to less time, I use it. I go through very fast. Thank you very much. Muazzam, it's over to you now again.
That was a very good presentation, Miqdad.
A very well done presentation by Muhammad Miqdad Khan. Thank you so much for sharing the application of quantum computing in medical field. Now, we have our next speaker, Tooba Angabeen, will discuss future of quantum computing in engineering and technology. Over to you, Tooba Angabeen.
Hello and Assalamu-Alaikum everyone. Hidden beneath our everyday world, on the infinitesimal scale of atomic and subatomic particles, is a strange and elusive realm. Today, the topic of my talk is Future of Quantum Computing in Engineering and Technology. My name is Tooba Angabeen. I'm from the institution of Anand University of Engineering and Technology, representing QCC from the Department of Applied Physics. Hearing my topic, you must be wondering, what is quantum engineering? Well, no wonders here. Quantum engineering. Quantum engineering is a revolutionary approach to quantum technology. It encompasses both fundamental physics and the broad engineering skill set necessary to meet the practical challenges of future. A quantum engineer will be trained to use the tools and language from quantum mechanics, electrical, electronics, software, systems, and computer science, as well as other physical sciences, etc. It's now the becoming a vast field as algorithms are already being written and waiting to be implemented. It seems like it's the beginning of the new era of quantum engineering, where today we have a schematic design and we need an engineer to implement it to the circuit. Maybe in the upcoming future, quantum computers with their high precision and accuracy will be able to do it on their own. Next, moving to what is quantum technology? Quantum technology is technology that works with and relies on subatomic particles or physics that operates on the quantum level. It can turn incredibly complex theories into practical applications, making existing technology more efficient or powerful, or creating brand new machines that couldn't exist otherwise. The functions of quantum technologies are derived from science that cannot be explained by classical physics, such as Newtonian laws, thermodynamics, or Maxwell's equations of electromagnetism. With the help of quantum technology, now we are looking forward to time machines to become a reality. Scientists said that they were able to return the state of a quantum computer a fraction of a second into the past. According to a university press release, the researchers who are from Moscow Institute of Physics and Technology, along with the colleagues from US and Switzerland, also calculated the probability that an electron in an empty interstellar space will spontaneously travel back into its recent past. The study came out recently in scientific reports. Well, the researchers don't expect you to take a trip back to your high school just yet. They added that the time reversal algorithm could be proved useful for making quantum computers more precise, and that's all possible with the help of quantum technology. Now the question arises, will the quantum technology impact engineering, and how will it impact if it impacts? Well, my answer to that question is yes. Quantum computers will be faster, meaning they'll be able to crack problems, solve equations, and enrich our understanding of the universe in the ways that we can't yet predict. There isn't a fully operational quantum computer capable of sustaining a quantum state for a prolonged time. But IBM has built a 50-qubit quantum computer that can generate and maintain a quantum state for around 90 seconds, which is currently the record. Normally, computers work in a binary system. Data is expressed as ones or zeros. Quantum computers work in such a way that ones and zeros can be ones and zeros at the same time. Quantum machines must be kept at extremely low temperatures near absolute zero to be able to maintain quantum states for extended periods. This has the potential to revolutionize engineering as we know it. Once quantum technology goes mainstream, it will be able to run powerful simulations and solve problems with thousands of variables. Parts will be designed and optimized far faster than today. Materials will be simulated to perform under any conditions, stress tested to a completely accurate degree. This will translate into a stronger and more efficient machinery, more capable programs, and higher levels of safety. Society is now on the verge of a second quantum revolution that will introduce never before seen technological capabilities. the doors to this transformation that were opened in the early 1980s when scientists developed methods for controlling individual quantum systems such as individual atoms, electrons, or photons, which was previously thought to be impossible. These methods form the basis of quantum technology, which is a field of physics and engineering that uses quantum particles for practical applications, such as sensors, computing, cryptography, and imaging. So we can see here a huge impact of quantum technology over engineering. Now let's talk a little bit about physics of quantum engineering and quantum technologies. The first quantum revolution opened our eyes for the orthodox and counter-initiative rules of quantum physics, such as wave-particle duality, entanglement, unitarity, and apparently instantaneous collapse of the wave function during a measurement. The second quantum revolution refers to the development of novel and innovating technologies, exploring to a maximum about these magical rules. The imminent quantum technology strongly simulates theoretical and experimental developments in quantum physics. Technical improvements and ingenious ideas in controlling quantum state preparation, quantum dynamics, and interaction with the environment paved the way to the new applications in communication, information processing, computing, artificial intelligence, meteorology, or sensing. Quantum engineering triggers the interest of governments and companies eager not to miss the quantum boat. The successful implementation of quantum technology still faces important challenges that rely on advanced comprehension of quantum physics, such as the suppression of decoherence for long times and at large scales, the control of quantum correlations in many-body systems, or the development of quantum logic. Many quantum physicists are committed to these new challenges situated on the border of physics and technology. Listening all about that, you must be wondering about future. What about future? Thinking about future has always fascinated people from all around the world. Most of the people care about more of their future than their present and their past. Imagine of the time when you will just think of building something and the model will be there in front of you in no time. That's surprising, right? But that's possible when you combine every field of science with quantum and excel in it.
Very well done, Tooba. So our first session ends here. We have our next session's chair, Dr. Intihab Ulfat, with us. He's a professor at University of Karachi, Pakistan, a great physics researcher and editor of Advanced Journal of Science and Engineering. Thank you so much, sir, for being with us. It's an honor for us to be with an amazing person and a great contributor in physics, research, and education. Sir, kindly allow us to start our session and share a few words with us.
It is indeed. Can you hear me, all of you?
Yeah, we can hear you.
We can hear
Welcome you from QCC and C.
Thanks a lot. Thanks a lot for your kind words and nice introduction. And I'm really pleased to be the part of this program. Actually, it is really nice to see people working and talking about a very new field, relatively new field. I mean, quantum computing. And it's good to know that the people from NED University especially are progressing a lot. Miqdad, I am really grateful to you for introducing me to this particular sessions. And of course, I have seen the papers they have published. They are quite nice. So I would like you to continue the proceedings and invite the speakers here to talk about the quantum computing in general. Thank you.
Thank you so much, sir. Now, our next speaker is Ma'am Erich, whose topic is quantum cryptography. Over to you, ma'am.
I was talking about the concept of quantum key distribution, that when it came first It came first in 1970s, but it was not until 1990s that we get physicists interest in this technology. And after 1990s, it has achieved remarkable for years now in a way that cannot be hacked theoretically. Okay, so this technology takes advantage of super fast computers, quantum computers, and holds the promise and threats both for our current encryption systems. But it also holds the promise of secure communication channels for key distribution. Okay, today's digital society is highly dependent on the security of data during communication and in storage both. For instance, in e-banking, e-business, e-health, or even in e-governmental channels. In recent past, we have seen events of cyber attacks on business world and data breaches at companies like Yahoo, GitHub, and Capital One, which is the bank giant, causes loss of lots and lots of, or I can say millions of dollar losses, and also compromised the sensitive data such as credit card numbers or social security numbers or bank accounts, etc. So it wouldn't take any longer or many large efforts to destroy the world economy by these cyber attacks. As the computer technology is advancing, the encryption systems we use today are becoming more vulnerable. Addition to the concern, quantum computers, which uses superposition and entanglement to deliver unimaginable computational powers. It's so powerful that it can crack the most adequate encryption infrastructure in literally minutes. Quantum cryptography is the one technology that can address this issue of long-term security. So before we discuss quantum cryptography in more detail and we see how this addresses the critical issue of security, let's have a look at the world of encryption. Encryption is basically defined as the process of converting useful information into a coded message using complex logarithms or mathematical functions so that the information cannot be fetched by a hacker. Uh, let's say I have to send a secret message, quantum, to an other secret agent, Sophia. What I will do to encode it, I'll encode it in such a way that for each letter I'll assign a number, and only Sophia will know what number corresponds to which letters. And then I will multiply this encrypted message with a number, a large integer that is a product of two prime numbers, like 13 and 14. So it will be very difficult for any eavesdropper to decode and check for all possible permutation and combinations one by one. It will take years for hackers to decrypt this code. It is a simple example. But if there are more complex mathematical models or functions or algorithms, then it will be almost next to impossible for any hacker or eavesdropper to attack on our any important information. Therefore, cryptographers turn to mathematics to develop harder codes using complex mathematical functions. Today, the RSA protocol is the best known encryption system. Please change the slide. RSA protocol is the common and best known encryption system that relies on difficulty of factorizing a large integer. It takes very long time to find factors of a large integer, so the longer the integer, the harder it is to break into its factors. Like, for instance, if I want to find prime factors of 143, it will be 11 and 13. It's relatively easy, but if I take instead an integer that is the product of the largest known prime number, that is 2 to the power 74, 207, 281 minus 1, and the second largest known prime number, that is written over here. So it would be a very difficult task and take years and years, or maybe even whole lifetime for the hacker to crack the code which is encrypted using this private key. So, but this is how our systems are protecting our data. So classically, this seems next to impossible. But for quantum computers with multifold super fast speeds, it could easily be broken in a very short amount of time, as classical computers look on all the permutations and all the combinations possible in one go. So it won't take much large for quantum computers to destroy a whole encryption system in a matter of minutes. So when you hear the term quantum cryptography, please change the slides. So when you hear the term quantum cryptography, we are more oftenly referring it to quantum key distribution. What quantum key distribution do that it doesn't actually encrypt user data, but makes it possible for users to securely distribute keys to each other, which can then be used for subsequent encrypted communication. Right? In quantum cryptography, photons generates encryption keys through their properties called spin, which changes as it passes through some particular filters, or you may call it in science terms polarizers. Um, Next slide. And this is what forms the most basic quantum protocol, BB84, we have now available currently. In this scheme of quantum key distribution, we have four filters, or you can say polarizers, as seen in the top right corner of the screen, denoted as bases. That is vertical, horizontal, and the two diagonals. We group these together as rectilinear bases and diagonal bases. When photons passes through any of these filters, their spin changes. This spin of photon is translated into key such that for horizontal and diagonal um, for the I cannot point it for the you can see in the zero column that for one diagonal and for vertical, it gives the value of 0, and if my polarization direction is um, horizontal and the other diagonal direction, then it is encoded as 1. So this whole picture is depicting an example we are going to discuss. So let's assume Alice sends very simple 8-bit size message. Then she randomly select two bases for each qubit. The two bases are, one is rectilinear and the other is diagonal. Now each photon is having particular polarization after passing these bases, which depends on both bit values and the selected filters. These photons are transmitted to Bob through a quantum channel. These photons, sorry, Bob doesn't know what filters does Alice chose, so he selected the filters randomly, making his own choice. He does this for each photon when he received. After the final measurement of photons is observed, Bob will communicate with Alice through a classical channel and discuss what filters they have chosen. They both have chosen what filters and for which photons. Then both discard the measurements where Bob used a different filter than Alice, because in doing so, if we take those measurements that in which Bob and Alice use different filters, there will be a 50% probability of getting a correct answer and 50% probability of getting a different answer. So all the pairs that are mismatched will be discarded. Next slide. Okay, so we have done whatever in the previous previous example. I have summarized this in a tabular form so to make it a more clear picture. So at first step, Alice created random bits, then randomly selected the bits, and then she transmit each photon through quantum channel without knowing Alice's choice. Bob selected bases randomly and for each photon. Then they two communicate through the public channel to compare their bases. Alice and Bob discards the results with different bases and then kept the same bits such as first, third, sixth, and eighth one. So they have a secret key that is called as shifted key 0101, and only Alice and Bob will know this key. So this gives us more secure communication than our normal encryption system. Next slide. The beauty of quantum physics bring okay. The beauty quantum physics brings to this solution is that if a spy tries to intercept the key generation, they will disturb the quantum system in such a way that it changes behavior and the hacker would reveal himself. And also both the sender and receiver, in our case Alice and Bob, will know that the key is being compromised. So as the hacker will try to measure the state of photon in between the process we have just seen, it will change the state of the photon, and then when Bob gets that what can say Bob gets that measurement, it will beside using the same filter as Alice, he will get a measurement that will not be same as Alice. So the security key, that shifted key, will be changed from Alice to from for Bob. So that's how our encryption is much securer in quantum cryptography. Okay, this technology has been in commercial use in Europe since 2007 and in US since 2010. For high value transactions like interbank communication and election result transmission, the benefits of quantum key distribution are sometimes worth the cost. This is expected to accelerate more and more in the coming years, and more integrated solutions are adopted for QKD. Eventually, this technology has the potential to change the encryption and cybersecurity world. As the systems and technology, sorry, not systems, technology gets more and more mature, it may even be possible to build entire encryption systems that are considered unbreakable. That's all from my side. Thank you so much.
Now, I would like to invite Mr. Rehan from CP Center of Physics Education for token of thanks.
Okay, first of all, I would like to thank the QCC, that is Quantum Computing Club, and CP Center for Physics Education for organizing such a wonderful webinar, which consists of, I think, 4 webinar series named as Steps Towards Quantum Computing. And I would also like to thank the organizing team, without whom it is not possible to hold such webinar. And I would like to name that members also. And I think they are Mr. Miqdad, Ms. Iqra, Mr. Mooazam, Mr. Shabaz, Mr. Rubab, Ms. Tooba, Ms. Kausar, and Ms. Afsha and Ms. Nazish. So I'm very thankful to all of them for organizing such a wonderful series of webinar. And of course, the speakers who make this seminar very meaningful for all of us. And I hope the participants would appreciate their efforts in clearing their concepts about quantum computing, although it is, I think, a new emerging field, and still a lot of work has to be done. But Our speakers tried their best, and I would like Dr. Aisha, who took pain for uh, their lecture in the last seminar webinar. Dr. Aisha, Ms. Nazish, Mr. Miqdad, Mr. Shehbaz, Mr. Muazzam, Iqra Naz, and Kausar, Eraj. So I am very, very much thankful to all these speakers who make this event successful. And in the last but not the least, I would like to thank the chairperson of Center for Physics Education, Dr. Akila Islam, the General Secretary, Professor Aziz Fatima, Finance Secretary, Ms. Kanis Fatima, Ms. Nazish, for their cooperation in organizing this event. And from QCC, Mr. Muazzam, Mr. Miqdad, Ms. Iqra, Ms. Kausar, Ms. Rubab. So I am really thankful to all of them and hope that this will be a beginning for the quantum computing, and inshallah we would like to continue these efforts and try to hold more webinars on this field. And I would request our organizing team and the members of QCC that they will try to hold some more webinars in the continuation of this webinar. Okay, thank you very much. That's all from my side. Thank you, Nazish. Thank you very much.
Thank you so much, Sir Rehan, for your kind words. Now, I would like to invite Sir Khurram, founder of QCC Quantum Computing Club, for some words.
Thanks, Iqra, and thanks whole team, and thanks Navish once again for arranging such a wonderful webinar. So I'll go back to the purpose of the Quantum Computing Club. For myself, my name is Khurram Hussain. I'm an alumni of NAD University. I live in California, and I run my own company here in IT and telecoms domain. So what is the purpose of Quantum Computing Club? So if you are from NAD University, me with Dr. Khurram and Dr. Sadek Kazi, we started AI Club to promote artificial education into the, and not only education, but practical education and startup culture based on AI products. Back in 2017. QCC is another effort to promote cutting edge technology and education and awareness in the domain of quantum computing. But QCC is a lot more exciting than AI Club in many ways, and a lot more challenging as well. Because quantum computing, as we know, it's basically we are working towards to build a quantum computer. That is our main goal, is that we want to have a primitive quantum computing machine built by our team at NAD University. All these efforts are done in order to achieve that goal. We have a great team led by Muazzam, Iqra, Tooba, Miqdad, Kausar, Shaheen, and besides them, there is a big numbers, and we are supported by some alumni and other groups like CPE and Nazish, Madam Nazish, who helps us to organize these webinars. So we are working towards our goal to build a quantum computer. I also had a discussion with Dean of the university, Sadek Kazi, last week, and here I want to communicate that how we are engaging leadership towards providing the right resources and right people for the job as well. So at NAD, we have decided to have a two-layer engagement. and with the quantum computing. One layer engagement is basically to engage ourselves with the current quantum computing platforms like IBM Cloud, make ND University the part of IBM Cloud Network, and maybe in future Google Cloud Network as well. The second initiative which we are taking is we have some quantum computing lab to establish that quantum computing lab or gear the resources towards making a quantum computer, which requires us to build quantum circuitry, whether it's on the conducting technology or the microwave. So that to build a quantum computer, which is a bigger challenge, which we want to accomplish. So we understand that the leadership from the institution, which is NAD University in this case, is required. There's a lot of resource and human resource capital build up for this purpose, for which we have built a great team in form of QCC, and will engage more experienced people once NAD University also leadership is fully engaged on this matter as well. So this is our main objective. We want to promote the education and awareness about quantum computer. That's why these webinars have been from time to time has been arranged. So yeah, that's it from me. If you guys have any question, feel free, please.
Okay, thank you so much.
And I would like to thank all the organizing team, all these young people who have worked very hard to make this possible. So very well done. Thank you very much, Iqra, Mooazam, Tooba, and Shehbaz, Rubab, Kausar. These are the young people who have been working very hard for these webinars. So thank you very much for that.
Thank you so much, ma'am. Okay, there is a quote. If the word quantum didn't shock you at first sight, then you didn't get it well. So it's just beginning and you have a long way to go. We hope you all learned something and enjoyed the session. We appreciate your presence because it was not possible without you all to have a whole webinar series on quantum computing. It's just the end of our webinar series named Steps Towards Quantum Computing to make a basic sense and intro about quantum computing. I'm very thankful to our honorable speaker who made it successful and fruitful to us. We'll come up with some advanced topics and research very soon. So stay tuned with us and be connected with us through social media. You can inbox your queries through email shared to you. You can find on chats. That's quantumcomputingclub79@gmail.com. You can also find us on Facebook at our page Quantum Computing Club. Once again, I'm thankful to all of you for being with us and to encourage us to do something better. I'm thankful to CPE, Center for Physics Education, for their precious guidance and support in both morally and practically. I'm very thankful to Ma'am Fatima, Ma'am Nazish, and Sir Khurram, and all other members for their supervision and guidance support, because it matters a lot for us. More and more thanks to all of you. Certificate of participation will be emailed to all of you. Once again, thanks. May Allah increase our knowledge, take care of you and all around you. Happy learning. That's all from me and my team. See you soon. Till then, Allah Hafiz.